All right, now that we know that the derivative of e to the x is itself e to the x, let's try and use that fact along with some of the other differentiation rules that we know already to find derivatives of some of these other functions here involving products, quotients, compositions, and so on. Let's look at the first one here. If you have a function that looks like that, it's not just e to the x. So you can't just say its derivative is e to the, you can't just say since the derivative of e to the x is e to the x, you can't just say derivative of e to the 3x is e to the 3x. It almost is, but it's got this other function in the exponent. It's a composition of functions even though you don't recognize it as that. The way you need to think about this is just think about it being written like this, e to the power of 3x, and there's a function inside there. The exponent is kind of like the inside of the brackets, right? It's the inside function. So when you're working out the derivative of that, just think, well, I first just ignore what the exponent is, right? If I have e to the power of some other function, so the derivative is e to the power of that other function, but then I need to multiply by the derivative of that inside function, which in this case is just 3. So the way you would probably write it is 3e to the 3x, right? Second one over here, similar thing, just a fraction in there. Think of it as e to the power of x divided by 3, or 1/3 x. Right? X divided by 3 is like 1/3 x. You don't need to use the quotient rule or anything like that because the bottom number is just a constant. So that derivative is going to be e to the x over 3. Start with just, it's its own derivative, but then you need to multiply by the derivative of that inside function, which is just 1/3. I'll put it in front right away. Some other ones here. Y equals e to the square root of x. Well, y prime is going to be e to the square root of x times the derivative of that inside function. Inside function is square root of x, so it's 1/2 square root of x. So you could write that, probably the simplest, most compact way to write that is e to the x over 2 square root of x. Can't simplify or cancel anything there in any meaningful way. Over here, y prime is going to be e to the 4 minus x times the derivative of that inside function. Derivative of that inside function, 4 minus x, derivative is just -1. So I'm going to put a negative right in front, and that's it. A few more here. E to the sine x, derivative is e to the sine x times the derivative of that inside, which again, this is like e to the power of sine x is the inside function here because it's in the exponent, so derivatives that times cos x. You could maybe put the cos x first or this, it doesn't matter. E to the tan inverse, which is also the same as e to the arctan x, whichever notation you like to use. Same thing here. Let's put a line down here. E to the, that derivative is going to be e to the tan inverse of x times the derivative of tan inverse, which is 1/1 plus x squared. So that one you could probably make into a little bit more compact way of writing it here. Now I put brackets in that when I wrote it, but it doesn't really matter. You don't have to. Maybe that's going to confuse the matter here if I do. All right, so that's that derivative. The last two here, you need to think about the product rule because this is a product. You get x times e to the x. So if I'm writing out what the derivative is here, I have, the first thing prime times the second thing plus the first thing times derivative of the second thing. That's just a 1 times e to the x. This is just e to the x. Not that I need those brackets, but it's just e to the x plus x e to the x. If you wanted to, you could write it in a factored form since they both have e to the x in common. You could factor out e to the x and make it times 1 plus x if you really wanted to, but either one of those is completely acceptable depending on what you want to do with it. Very similar one over here. Derivative is x squared, derivative of that, times e to the x plus x squared times derivative of e to the x, 2x e to the x plus x squared e to the x. If you wanted to, again, you could factor out actually x e to the x if you want, and be left with 2 plus x here. But again, either one of those are fine depending on what you want to do with it. All right? So that's a look at the derivative of e to the x, the natural exponential function, and a few examples of more complex functions, finding their derivatives, and incorporating other derivative rules,